Here we've got a rotation through pi over 4 degrees, and we want to find the matrix that does that rotation anti-clockwise, pi over 4, origin 0, 0. So normally what I would do is I would take A, B, C, D. This is my transformation matrix, my general kind of transformation matrix. I find A's coordinates, which is 5, 1, and then B's coordinates and so on, and I multiply them and I get the transformation of A. Now the problem here is that A here has a horrible number, well, I've got no idea. So this is going to be very difficult to set up simultaneous equations. So what I'm going to do is I'm going to write out the transformation like this, and I'm going to do complex numbers. So I'm going to have complex numbers on the graph. So I'm going from A to B, and what I do is, in general, I say that A, the original one, is R CIS, and here is my angle going anti-clockwise, which is the Greek letter phi. So that's my A to begin with. Then the transformation is by this many degrees, which I'm going to call theta. So the transformation can be written in complex terms as R, which is exactly the same value here, the same modulus, phi plus theta. So I can write it out like this. Now you're going to find the algebra, you may find the algebra quite difficult, and you might have to pause the video to follow it all. But what I'm going to do with this is I'm going to split up my Euler form using the index rules, go back into CIS form and write it out as R, the EI theta, and the phi there. Then we're going to just sorry, this is a multiply here, so I've made a little mistake there. It's actually a multiply. So now I'm going to multiply these out together. So this times this gives me these two, and I'm going to multiply this by this, which gives me plus I squared, which becomes minus I squared. So these are the real part, and here is the imaginary part. This one times this, and this one times this. So just pause that and have a look at it for a minute. But we're going to keep going with that. And we're going to take out the cosine theta part here, and we're going to put this R in here. I'm going to take out the sine theta part here and have its R times sine phi. Now the reason we're doing all that is because and we're doing the same here, is we're going to then replace this with our x and our y. So where do these come from? This is here, this coordinate is x and y. So my x coordinate was cosine theta x, and my y coordinate was sine theta y. So I can replace each of these with a y, each of these with an x. So we're getting there. Again, you might want to pause and just make sure that you know exactly what's happening here. From there, what we're going to do is we're going to put this part here into a matrix. So imagine we've got x and y. What's the matrix that we're multiplying them by? So we get this, cosine theta and minus sine theta times xy gives me that first part. And the second part is this times this. So this becomes the general transformation matrix for a rotation through theta degrees. And we're going to double check. If you did the investigation on the PowerPoint, you'll see that all the determinants were 1. Well, the determinant of this matrix is also 1.